Okay, let's talk about analyzing graphs of functions, part one, and this is continuing, and we're talking about finding X and Y intercepts. So X-intercepts are the solutions to the equation f of x equals 0. That's when you're given a function, you can set it equal to 0 and solve it. X-intercepts are also called roots or zeros, so they can be one of those four things. X-intercepts, solutions, roots, and zeros all are talking about X-intercepts. On a graph, it's where it touches the x-axis, so sometimes you're given a graph and you just literally need to look at it, and sometimes you have to do more work, which we'll talk about in a minute. The y-intercept is when you plug in x equals 0 and you can find it quickly. And then on a graph, it's where it touches the y-axis. So let's look at some examples. So for example 1, if you are just given a graph, and this is nicely plotted where they're easy to see, I could say the x-intercepts of this graph are at -5, -3, -1, 1, and 3. So I should have labeled this. Let me go ahead and just write that down on here. But those are all equal to 1, like each box is equal to 1 unit. So those are easy to look at. We could also write it as ordered pairs where the y values are just 0. So I just wrote them out with y being 0 as ordered pairs. And then the y-intercept is also easy to find because it's just right on 4. So again, each little tick mark is equal to 1 unit for that one. Then let's look at equations. So from this first equation, if we're given f of x is equal to 3x squared plus x minus 10. The y-intercept is always really easy because you just plug in x equals 0. And so that's what I've done first. I just substituted x equals 0 into the function and simplified, and you get -10. So you have 0, -10 as your ordered pair, or just that the y-intercept equals -10. It's also considered like the c value in the quadratic form of ax squared plus bx plus c. So that is always your y-intercept, which if you know that, it would be really quick to just pick that out. But if not, you can plug in x equals 0. Now, if we want to find that x-intercepts, they take a little more work. We have to solve the equation to find those. So I set it equal to 0. So notice you're given f of x, but you can just replace it with 0 and then solve the equation from there. And then I have done some factoring. So I multiplied 3 times -10, and I got -30. And I figured out what would help me multiply to get -30 and add up to get the middle value of 1 for b. So then I wrote out my binomials. I put in 3 into both. So 3x went into both binomials. I put in the +6 and the -5, and then I just had to take away a 3 because you only need one 3 and I have 2, so I had to divide one out. We call that like wrong way factoring. And then you're left with what you really need, which is x plus 2 and 3x minus 5, which would give you back what you started with. So we had to factor it out so that then we could set each factor equal to 0 and finish solving the equation. So if x plus 2 equals 0, x would equal -2. And if 3x minus 5 equals 0, we could solve that equation and get x equals 5/3. So after a little bit of work, we end up with our x-intercepts of -2 and 5/3. So here's one more example. If you're given the equation, g of x equals the square root of 10 minus x squared. Again, the y-intercept is pretty simple. You just have to plug in x equals 0. So then you get the square root of 10, which is approximately 3.16. So that's where our y-intercept would be located on our graph, 3.16. And we can just write it as an ordered pair or put the value. But then for the x-intercepts, again, it takes a little more work because you have to solve the equation. And so I put 0 in place of g of x, and then I started solving. So I had to get rid of the square root sign, so I squared both sides. Then I needed to get x squared on one side, so I added it to that side. or to both sides, so that it moved over. And I got x squared equals 10. And from there, I took the square root of both sides and got plus or minus 10. So again, I added x squared to get x squared equals 10. And then I took the square root of both sides and got x equals plus or minus 10. And that gave me 3.16 or negative 3.16 for my x-intercepts. Okay, so let's look at finding the x and y intercepts using your calculator. Sometimes it's just easier to type it in and use the calculator, and sometimes it's easy to do it by hand. It just depends on what you're given. So if we wanted to find it in our calculator, these are a few steps to keep in mind. You want to type the function in y equals. You want to graph it and adjust your window if you need to. Then there's two options I'll show you in just a second. You can either hit second calc option 2 and use the trace button on your calculator and go left and right bound. Or you can type in values to go left and right bound. And then your x-intercepts that are not decimals, that are like integers, regular, like clean numbers we could call it, will be in the table. So we'll check that as well. Okay, so let's look at example 1. 3x squared plus x minus 10. So I hit graph. I can see my graph pretty well, so I don't really have to adjust the window too much. And I'm just going to see what these values are. So if I check the table, I would see where y equals 0 is going to be an x-intercept. So it looks like there's one of them in my table. Don't go too far, but you can kind of tell that one's a nice integer that's in the table. So we would say one x-intercept is equal to negative 2. And then we want to find the other x-intercept. So now we've got to go to second trace 2. And we just need to find this one. We found negative 2 in the table. So now we only need to find this one value. So we have put second trace 2, and your calculator is asking you for a left boundary. So you could either use the trace feature, meaning you find that little blinking spider looking thing, and you trace it around to where it's sitting to the left of the point you're looking for, and you hit enter. Let me move this up so you can see what I'm pushing. So you hit enter, then move to the right, so above it a little bit, and hit enter twice, and it gives you 1.6 repeating. The other way to do it is to hit, let me move it up a little bit, second trace 2, and you can type in values. So you notice that looks pretty close to 2, but I'm going to type in a value to the left of 2, like 0, and hit enter. And then I'm going to type in a value I know is to the right, so like 3, and then hit enter twice, and it'll do the same thing that the trace button would do. So we still get negative 2 in the table and 1.6 repeating on using the other method. So if we want to get a value for that, let me show you what you can do. You can repeat the 6 all the way over and then hit math, enter, enter, and it would give you back the 5/3. So that was the same example we did over here when we factored it out. So I just want to show you that's what we did by hand, and now we just did it really quickly using our calculator. So let's do one more example. I'm going to type in the absolute value of x minus 2. So I go to math, num, option 1 is absolute value of x minus 2. And then I hit graph. So let's first check the table. And there are 2 x-intercepts right there in the table. So x would equal negative 2 and positive 2. But let's just practice using that other method as well. Get a little more practice. So we know they're at 2 and negative 2. So let's hit second trace 2 and type in some values. So let's type a value to the left of negative 2, like negative 3, and then a value to the right of -2, like -1, and hit enter twice, and it lands right on it. So then you'd have to hit second trace 2 again, and we know this one's at 2, but let's just use the trace feature this time. So we trace over, hit enter, and then trace to the right and hit enter, enter. So we can practice those other ways to find it.